Hi guys, in this video we'll be doing factors affecting rate of enzymatic reaction, and we'll be focusing on pH. Okay, so let's start by defining the pH. The pH, okay, basically it's a measure of H plus hydrogen ions, okay, hydrogen ion concentration in a solution. Okay, so when the lower the pH, okay, the higher the hydrogen ion concentration, okay, and hence the solution is more acidic, okay, and vice versa for higher pH. Okay, so all the enzymes in a body, okay, work best at their optimum pH values, okay, and if that particular pH is changed, okay, I'm not saying increased or decreased, I'm saying both, okay, the rate of reaction gets lowered, okay. It's different from temperature in a way that when we increased temperature, most of the time the rate went up, right? But here, if you slightly change the pH, the rate will always go down, okay. Either you increase the pH or decrease it. Okay, now the reason behind this is, as we have already studied, that enzymes are globular proteins, and they have specific ionic bondings, okay, ionic bondings between our groups or in our groups, okay. And due to these ionic bondings, okay, since hydrogen ions are ions, so basically they disrupt these ionic bondings, okay, and this is basically the problem. So either they are low in concentration or high in concentration, is more acidic or more alkaline, we have a definite impact on the ionic bondings. Okay, so if that happens, okay, the enzyme loses its shape, okay, and hence it also loses its active site, okay. It loses the active site, and may even become denatured, okay, if the fluctuation in the pH, okay, if the fluctuation is high, okay. Now obviously the substrate molecules are unable to bind to the active sites of the enzymes, and hence no formation of enzyme substrate complexes, and obviously we have no products. Okay, so that's basically the summary of the effects of changing the pH or the pH. Okay, now let's talk about the enzymes of the human body. Okay, so most of the enzymes at human body, okay, they work fastest at around pH of 7, okay, that's around neutral, okay, but may show, okay, variations, okay. So let's say like the enzyme pepsin, okay, don't go to its name, it's not Pepsi, it's pepsin. That's a protease, okay, and it works best as acidic pH, of around around 1.4. Okay, whereas we have another enzyme, trypsin, similar sounding names, right? Okay, trypsin, it's also a protease. Okay, however, it works best at pH of 8. Okay, so we have variations. We have much variations in different enzymes, and that's just in the human body that we talked about. Okay, all the different organisms have different optimum temperatures or optimum pH for their enzymes. Okay, and it depends on the organism. So with that, let's conclude this lecture. Take care. Okay.